group, you guys are fun today.
Hi, B group. A group is not my favorite. They are not my friends. I don't like them. They are mocking me for the way that I start this class out. One of them, it's mask break time, by the way.
Oh, really?
One of them, I just can't even. Okay. This is going to be a really short video today because we took our vocabulary quiz. B group, you will be taking your vocabulary quiz tomorrow. I gotta take this off, I'm hot. Also, you'll notice that the screen looks different because I don't have my projector anymore. I got my TV, and that's also why this is a short video, because Mr. Coppola was just in here putting everything together. That's his name.
I call him Mr. Calculator.
I think that's how you say his name.
We just call him the IT guy.
So, hopefully this works. It's way on the side and there are cords everywhere, but I'm trying really hard to be okay with this. But I think it's gonna work. We can do this.
We can put the cords in the ceiling.
I'm gonna need the cords somewhere because...
We can put them up through the ceiling and then back down.
Yes, we can do that.
Oh, we need a chair.
I have a chair,
Okay,
but we can't do that right now.
We can do it after
Because
this
I'm
one.
going to trip or electrocute myself. Can you see the cords that are here? There is just a ton of cords
Yeah, we can do
that are all over the ground that I'm going to trip on.
Don't worry about it.
So we have a visitor. Hello, I am recording for my class right now.
Get out.
No, you don't need to yell, get out. Can I, just so you know that you are on. I'll see you next period?
Yeah.
Okay.
I'll just ask you next period.
Okay, thank you. All right. So we are looking, I don't know what he did to my stuff. Nothing's where it's supposed to be. All right, let's do a couple of notes. I was telling the A group that it is looking like we are probably having a test in here on not this coming Monday, but the following Monday. So in the meantime, you're also going to need to be working on those packets. And that's, I know that the boy back there sent me an email because you had already done chapter 2 notes. So make sure that you're doing those packets that I gave you. Those will be due.
The day of the test.
Today feels like Monday. It'll be due the day of the test, which I think is the 28th, which quite possibly could be everybody back together.
That's so
Which would be so awesome.
Let's go!
I do need you to know, though, that there might be a fight because Dad wants to sit in that seat. I don't know what's happening.
They're not paying attention.
I miss Brandon. Or I miss.
That's okay. You can say it. You can say his name. I can't say his name, but don't yell at his name.
I miss Brandon and I go, Logan, you can't say names. And then I just said Logan.
That's okay. Girl in the green. There might be a fight over your seat because that's also where Dad sits. And he said he was going to fight you. So you two can work that out.
Dad knows that I sat here last year.
I know.
So that's why he wants it this
It
year.
might be a fight.
I don't care. I'll kick
I will
that.
throw down to the
Did you hear that, Dad?
Yeah,
She's
Dad,
coming for you.
I'm coming for you.
Okay.
Sorry,
So
Mom.
weird that we call him Dad. But he has the best dad jokes. Man. Okay, today are going to look at hydrogen bonds. So on Tuesday, we were looking at polar covalent bonds, like in water. So within this one water molecule, there are oxygens and hydrogens. The oxygens are holding on tighter to the electrons than the hydrogens are. So there's a slightly negative charge to the oxygen side and a slightly positive charge to the hydrogen side. So within this one water molecule are polar covalent bonds, U. What's going to happen when I touch the screen? Because I'm going to touch the screen because I can't help it.
Nothing.
Nothing. I'm just going to get fingerprints, and that's going to drive me nuts.
And it might feel a little weird when you touch it because it's like a screen, but other than that, you're fine.
Oh, I want to touch it.
Just touch it. Touch it.
Oh,
Touch it.
oh,
on the
guess
part.
what?
There's another one.
Guess what? Yeah, there is.
Touch it on the part that actually has the screen lit up, and you'll sort of understand what I
He
mean.
forgot to take this part off.
And that's because that's
Oh, because what?
the difficult part.
Okay, so
This is what we do.
we today are looking at hydrogen bonds. Here it goes. I feel like I'm on one of those, I don't know the letters and I don't want to say the wrong letters. ASMR, is that what they are?
Sure.
Yeah.
You don't talk about this videos?
There's more to the It goes all the way around.
No,
No,
he
you
got
got
he got all of the other ones. He just didn't get that bottom one.
Sometimes
Okay, he got
some
those.
more.
How do you work this?
Or what?
That's what you said, buddy.
the type of bond formed between the water molecules. Okay, so within that one water molecule is polar covalent bonds. Seriously, sit down. I know this has been a very odd class, but we do need to do some work. Thank you. You're welcome.
Unlike one of us.
So, you are too. You are doing okay. It's not maybe necessarily what you're used to, but you were doing excellent for being never having biology before.
Okay.
And we're all moving.
You're a newbie.
Yeah.
Logan's
Okay.
in the AP world.
You're not new. You've been in here before.
Yeah, failing Bio 1. That was a lot.
Now you're failing bio too.
I'm not
So
failing
AP.
Bio 2 yet.
You're not. You're
No,
gonna
I'm
do
at
fine.
AP. What's
You
up?
are gonna do fine.
Yeah.
You can't do it.
Logan's only in like 100
You got it. Okay. Oh, look at that. My mouse is over here.
Uh-huh. That's what it does to you.
I know, but I
That's so fancy.
can't see it on the other one.
Yeah.
So the hydrogen bonds are the bonds that are formed between the water molecules. So within this water molecule are polar covalent, polar covalent, polar covalent, polar covalent, polar covalent. Within each of those are the hydrogen bonds. They are, you'll notice, they're relatively weak bonds. Why do we want the hydrogen bonds in water to be weak?
So we can split it.
So
So you
we,
can
like,
swim.
we use it, like we drink it.
What else do we do with water?
Give it
bathe
to
in
trees.
Breathe it in, breathe it out, right? So, what is happening in my cup right now?
You're shaking it. Ice.
Obviously, there's ice.
Melting.
Right, so it's in a solid form in this cup, right?
Yep.
And it's in what other forms in this cup?
Liquid.
Liquid,
It has
and
to be
then
able to change-
it went up
Gases
here.
maybe a little bit.
Say that again?
It has to be able to change easily.
Right, we want it to be able to have those weak hydrogen bonds because we want it to be able to change easily. We want it to be able to go from a solid to a liquid to a gas relatively easily, and it's doing it in this cup. Yes.
So what about silicon? Like how silicon is like concrete.
We're going to talk about everything else in a minute. Okay, so just give me a second. Or actually, it might not be today. So because of those hydrogen bonds, like everything else on the planet, like everything on this earth, everything has a freezing point, has a boiling point.
Even
Okay.
humans.
We do. So even things like alcohol, because sometimes people will be like, well, alcohol doesn't freeze. I can put a bottle of vodka into the freezer and it doesn't freeze. No.
Down the freezer.
It will freeze, but it might not freeze in your freezer because your freezer isn't cold enough.
Why does
So, pardon?
Because
Why?
Because it has a lower freezing point and your freezer doesn't get that cold.
It's sort of like gasoline versus diesel fuel.
Exactly.
Yeah.
Exactly. So everything has a different freezing point, so it's there. So the freezing point for this slate, for this carbon, is not like a whole lot, right? Because it's in solid form sitting in front of you. Okay. This water is not too awful to get into a frozen solid form, right?
It's okay.
Okay. So the other thing that happens here that I want to talk about though real quick is water. I don't know where we're at. Whenever water freezes, it does something different than everything else. So what happens to the carbon molecules whenever they freeze?
They stop moving.
What happens to this? Do they they're liquid and then do
Closer together.
they get closer together?
Like,
What
like
happens when water freezes?
They expand.
The molecules move apart, right, because they
Depends
said
how
it
ice
expands. Now, you have never heard my lecture on this, so you need to listen to this part because I will very easily mark this wrong.
Okay.
If I say, why does ice float? And you tell me because it expands, I'm going to mark it wrong.
It's because ice is less dense.
If
than
you
water.
tell me it's because ice is less dense than water, I'm going to mark it wrong. So if you
Well, it is, but
It is, but that's not why. It is less dense than water, but the reason why is because the space between those water molecules expands. The water molecules themselves don't expand. The space between the water molecules expands. So then that is the thing that makes the ice less dense, that then causes the ice to float. Okay, so hydrogen bonding does weird stuff that nothing else on the planet does. So we did all that. Okay.
water's just always been weird. That's why humans like it so much or something.
And we're part of it. It's most of us. So water is cohesive. These are some of those things you learned way back in Bio 1. Yes, water is cohesive, so those hydrogen bonds stick to each other and they form like a layer. It's why the water striders can walk on the water It's why the Jesus lizard can run across the water. It's why if you were to jump, like you do a belly flop, and it hurts because that's surface tension. Or if you were to fall off of a really tall bridge, why it would be like falling onto concrete, because it basically is because of surface
It's
tension.
like cliff jumpers throw a rock before they jump.
Exactly. So you would need to throw something like a rock if you're a cliff jumper or whatever in order to break the surface tension so that it doesn't hurt you.
That would have to be a big rock, though.
Yes.
I saw a thing about that on Mythbuster.
Right. So it has to be in order to displace the appropriate amount of water, and it will be dependent on your velocity and also the size of you, so your mass and the
It takes
velocity.
way too much
So
mass.
if that were a rock,
Right.
that's the size of me.
Yes, at least the
Basically.
size of your head.
Because we don't want to break your head. We can break the rest of you,
Just not the head.
not the
His head's already broken.
head. That's different than adhesion. Adhesion causes capillary action. That's where water holds onto something else. So like here we have a paper towel with Kool-Aid or blood, probably Kool-Aid, because it's not at my house. For my house, it'd be blood. So anyway, it would be, you just stick it in here. It wouldn't be blood. there's no blood in my house. I know how to have a clean room. So you would stick the paper towel in, and that paper towel is going to hold on to the water is going to hold on to the paper towel and move up the paper towel.
Is that celery in a jar?
It is. So this is one of those things that you've never done. This is amazing to me that it's so clear. It was so not clear
Welcome
for
to
so
4K.
many years.
Welcome to 4K instead of 768 or whatever
2003.
earlier. That technology was around in the
No,
80s.
that thing, I think, was from...
Right, but the
I don't know.
resolution that it supports
Yes,
is from
you're
the
right.
80s.
Yes.
So it's terrible.
Everyone like in the world has done this experiment except for us for some reason at the school. But if you take colored water and put celery in it, even though the celery is already cut, because of capillary action, that food coloring moves up the stem and it makes the leaves change. Or you can do it with flowers. So if you have like a white rose and you want to make it a purple rose or a pink rose, then you can put it in water with pink food coloring or red food coloring or whatever food
Is that
coloring you
how
want.
they change the colors?
Yeah. Not all of them. I mean, we have different varieties of those flowers, but
Yeah, we
Yeah.
genetically changed them.
but there are some colors, yes, that don't happen
Or
in nature.
sometimes they just paint
Or like those crazy daisies.
Like they have
Which
yellow
I'm-
celery.
Okay, that's
That's capillary action because the water is holding on to something
That's
else.
so awesome.
Water also stores heat. We call that,
So can you make a black rose?
pardon?
So can you make a black rose if you get the right mixture of food coloring?
You probably could. Although probably because it's white, it wouldn't be able to suck up enough water to make it super
It'd be
black.
more like
It would be
gray.
more like a gray rose, which
I
actually
black-
sounds really beautiful.
I had
It sounds
black
really
roses
cool.
in my prom bouquet
Did you?
one year, but they were like painted.
Oh yeah.
They were like spray painted with glitter and stuff. Very beautiful.
Or sometimes the black roses are like super dark red. But
Yes.
that gray rose sounds like that would be gorgeous.
Can you
I
know
want
we're
a
doing
gray
science?
I want gray roses now.
Let's do science experiments.
That would be so pretty. Gray and purple. Like gray and lilac roses. That'd be really nice. Huh. Interesting. So anyway, specific heat. Water's ability to store heat helps moderate your body temperature in the climate. So it wasn't as cold this morning, but Tuesday it was really cold. You were probably still sleeping because you were on the line. But if you look at a pool or a pond or a river, you'll see the stuff. Okay. A group, I'll see you on Monday. B group, I'll see you tomorrow.
Tomorrow.